Hi everyone, welcome to this fifth episode of the Git series, the series where we try to implement Git using Scala and Zayo. And in this episode, we are going to finish what we started in episode 4. In the episode 4, we focused on hashing a stream of bytes. And in this episode, we are going to plug what we have in order to hash a file, and maybe hash files if we have time. So this episode, we are gonna rearrange a bit the hash object use case, and we are gonna implement the hash object with the file, and we probably gonna have to integrate the concept of response to the use case in order to have a different kind of response and the new command. So let's dive into it straight away and see what we can do. So I'm going to start by refactoring the hash object use case. Okay, so initially I thought that this thing here could be an extension, could be used as an extension using the feature of Scala 3. So in Scala 3 there is this extension, but actually we don't really want to extend the IO. I don't know if you can actually extend an object because this the sink is actually an object. So I might just put my methods inside another object. Okay. So if we look at the project structure here, okay, so I'm not too sure where I could put that. So I'm just going to create a file in the root of domain. Extension, which I'm going to call sync extension, and it's going to be an object. I'm going to put this inside the sync extension. So that's a bit weird here because usually this kind of thing are more in the infrastructure package, but here the domain is actually related to that. Let's hide the type. So now we can use sync extension chow and sync, making that hopefully a bit easier to read. Let's see if our test still passes. I wonder if I think the sync extension needs to be imported actually. Okay, yeah, we can see that is missing here, so I'm just going to import it. Import git.main.start, and we're going to run that again. Okay, perfect. Our test still passes. So the next thing is then to you have this hash object commands. So actually, if I come back here, and if we try to find loop run, okay. So last time, or the previous time, I don't remember, we added this hyphen text here to specify text, but not now. What we want is actually to specify a file. I'm looking to see if I can write a test that would cover that. So we could, like, for instance, hash the content of README, but it's going to change in time, and we kind of want a file that is not going to change to be able to verify that the hash of the file corresponds, to be able to add that in a file in the test. So I'm going to create the resource file, the resource directory resources in the test, and we are going to create a new file within that. It's going to be hash object file one.txt. I'm going to generate random contents. Okay, so we have our file. Now let's try to see what's the hash of this file. I'm going to use the command git hash object, and we said that we can specify directly the file after. We still need the minus -p src test slash resources hash object file1. Actually, we don't. Okay, so we don't. What I want to do is have the same results. I'm going to go to the main spec and write another test. So the first test was print the hash of the string parameter test content. And now we are going to write a test, print the hash of a specified file name. And actually, this test is going to be quite similar to the other one. So I'm just going to copy that over. Okay, we still have this console recorder thing that is not very, very pretty. Is there a quick win that we can do here? Okay, I don't want to diverge too much from this episode, so I'm gonna leave it like that for the moment, but this... Okay. And we said that hash needs to be that. Now if we run main spec, okay, so that makes sense. We have the test failing, and because it goes to this thing here that throws a non-implemented exception error. So what we can do then said that if we have a file, if we have files, so we know here that we want to have several files. Okay, for the moment, I'm just going to start by one file. So if we have the one file, so we have a list here, and we're going to take the first argument. And the first argument, we are going to call the usecase handle command. But instead of hash object command, it's going to be something slightly different. So let's see. Let's open that. Here I'm going to do an enum instead of a case class, and we're going to have one command for hash string and hash text, and one command to hash files. So we have case hash text string to hash. I'm going to rename that text to hash to be more consistent. And then we're going to add another hash files. I'm going to hash file because we just want to hash one file for the moment. And I'm going to specify file name string. Okay. Okay, so now our code here accepts two types of commands, but we do need to change the handle command in order to accept them. So what I'm going to do here is I'm going to match that. Okay, we have the exhaustive by IntelliJ. So either we have the hash text, and the hash text is going to be what we have already here. So from iterable, z-string from iterable, hash object commands, so we can just take text to hash get bytes with the encoding. And we didn't implement that yet, so I'm going to throw 0 error here. And this result of the match is going to be byte stream. Okay. So now zero is that error. Okay. Let's keep that for the moment. I'd like to compile I'm gonna run the test again to see if everything is compiled. I suspect not, but let's see. Okay, so as we can see, we have few errors, and the first is in main. So obviously now we need to specify hash object command hash text and hash file command hash file. Okay, and here it's not text, it's file, and actually even file name. Okay. So this import seems to be incorrect. Yes, I'm gonna remove it. Hopefully it's not going to break everything. So the next thing that is failing is the hash object use case spec. Use case spec. And here we have hash object command dot hash text, and instead of str to hash is text to hash. Okay, so we should be good. I'm just gonna go back to the main. Yeah, actually I still need to have that, I think. Okay, let's see if we are compiling now. So obviously we still have the same error because we just moved the implementation that implemented somewhere else. So here now we need to implement that. And last time we said that there is a method here that we can use from zstream, which is, I hope that IntelliJ is going to be able to help us with that. I think it's from file name. File name. Okay. So last time we opened the code source of this function and tried to look how it is implemented. And we can have a very quick look again. So this function basically handles the file, handles the opening and closing the file. So we can see that this first bit here tries to open the file and says that when it's finished to close it, basically. And then we start, it uses the channel to first allocate a buffer in memory, and then what it's going to do is going to read from the channel, so the file channel, and put the bytes in the byte buffer that was created, as long as the byte is not -1, which indicates the end of the file. I think this flip is to like kind of empty the byte buffer, and then it transforms into chunks. So this allows to have an efficient way to read a file because it limits the number of system call. So this is going to give us as well a stream of bytes. That was the intention of doing that in the first place, to have our function handling a stream of bytes. And if we run that, okay, says passes. Great. Okay, so now if we go back to the hash object command here, we have actually, we can actually specify several files. So you can see that if I specify several files here, we have a list of hash that corresponds to a list of file that corresponds to in the order that we specified here. So the first hash corresponds to the first parameter and the second to the second. That'd be good to have that as well for our program. If we look, actually something that we can do is run Okay. So if we try to run our program again and specify the path of the commands of the file here. Okay, that seems to match. We can also try to specify the README. Is it README? Yeah. Okay, it's gonna match with that. So let's see. Okay, it seems to be matching as well. But what we can't do at the moment is specify that, and then, for instance, README. What's gonna give us is only one hash. So here, something that is a bit annoying is that it's returning a string, and one thing that is very important here is to specify the right types. So we could keep a string here, and in this, have this logic of concatenating the hash of the object and forming a string of one hash per line. That would work, but that would be very wrong in terms of hexagonal architecture, because we want to keep the options open for the user of this handle command. So we want to, if, for instance, let's say if this handle command is used by HTTP API or some kind of streaming API, we are giving a formatted result that is unusable by this. This is so this format here is very specific to the console. And the console is in the infrastructure. That's just one adapter to for our program. But we could imagine as well having other type of adapters. So we want to give as much latitude as possible for the users to handle the results the way they want. So I'm gonna here create another enum, or maybe just a case class here, which is gonna be hash objects results. And this case class is gonna handle is gonna be written instead of string here, and is gonna give is gonna feedback the result of this command to the user of this use case. So what I'm doing here is I'm replacing hash object result, and so for the moment this is just gonna be that, and oh yeah, hash object result takes just one single hash for the moment. Okay, so you can see that having an object here, modeling, is going to help us to have an extensibility with this feature in the future as well. Typically here, we are going to want to add a list of hash or a vector, whatever, of hash. If we needed to change the type for everywhere it's used, then it's a lot of work to change. There's a lot of change potentially if we kept string here and replaced by a list of string. But once we have an object wrapping that, it's potentially less changes. So it's easier in terms of maintainability. So here, actually, I might cheat a bit, going one step quicker. Instead of having just a string, I'm going to give a list of string because I'm going to have to change things everywhere. So I might as well do it right straight away. So if I open the test, so here we have instead of the string, we have the hash object result. So what we can do is saying hash.hash. So this is going to be, okay, so I'm going to call that result or hash object result. Hash object result, here hash object result at hash should be equal to a list. Okay, if we open main, that should be the next thing to update. So here's going to be interesting. If we run the main tests, the main spec actually, we should see that the tests are failing. It's going to print the result, the case class itself, and not the hash. So I suspect that's where the tests are going to be useful. Okay, yeah, that's what I was saying. Look here, it's actually printing hash object result with the list and containing the hash. So I'm quite happy here that I could demonstrate that the tests were useful. So what we are going to do here is I'm going to use the o dot. I think there's a for each function that takes the hash. So here we are returning a list of string, and we need to call this effect the print line here for each string that we are returning. So there is this useful Zio for each, which I believe is Zio for each. It's the name of the function now. So this Zio for each, we're going to give the collection as the first argument, and then we're going to give the effect that we want to execute. And the effect here is print a line. And I suspect this is going to work straight. So here it's taking a call by name argument, and apparently we can't do that like that. We can't specify a call by name. So let's try to see if we can call with the parenthesis underscore parenthesis, turn that into a function. Okay, that works. Okay, so now let's extend the test here to have several files. So the first thing is I'm going to create another file. I'm going to duplicate this file, call it file 3 for instance. I'm going to add more stuff to this file, and we are going to specify in the test that we want file 1 and file 3. Perfect. And we expect to have run hash object. Okay, git as object with file 3. We should have this hash, so let's add it here. Cool, and we should see now that the test is failing. Okay, so as we can see, obviously the test is failing because it's handling only the first argument for the moment. So I'm going to first change the main in order to have this taking a list. And I'm going to change that to a list of string. And so now our hash commands accept just a list of string. So now we have file names. Okay, and so this is now a list of string corresponding to the file names. And here is basically is able to read one file at a time. So I'm going to refactor a bit this function here to be able and extract this in order to be able to use it in every element of the list. What we don't want to integrate though in extracting that is this object result. So I'm going to change that a bit. Instead of that, I'm going to put back that. I'm going to extract that into a method here, which is going to be hash stream I by stream. Okay, perfect. So now we can call this hash by stream with the file, and we can then flat map. So the problem is that this returns just a string here. So we do need to return the hash object result. So I'm gonna flat map the result of this function to be able to transform the result to the string that we receive to the object result. So here is the flat map is going to take the hash, which is the string here. I don't know if you can see it. We can see the string, and we can have something quite similar to what we had before. Because here we just want to hash only one, so that's why we're putting the list explicitly, but here the implementation is going to be slightly different. So actually I'm going to use the same kind of logic that we used before. We could even use some parallelism here. Okay, so if we look at that, we can see that this function is going to execute our effect here, f, for each element of the collection in parallel. So that sounds quite good. Like if we can have a quicker result. I think that we still keep the order. This is not specified explicitly, but I think we still keep the order. We can check usually. Okay, I was expecting that there would be some more documentation here. So I'll go with the assumption that this keeps the order. That would probably be something to verify in real life. Okay, so what we want to do here is for each file names, we want to actually, I'm going to explicit here the file name explicitly. So we want to read the file and then hash the file. So I'm going to use the for here. Sorry, actually, I don't need the for. I just need to read. This Z-stream here doesn't return Zio, I don't think so. Yeah, it returns Z-stream. So we just need to hash the byte stream of that and its file name here. And we can have a similar result here. This for each par is going to return a list of hash. So I'm going to call that hashes. And here, okay, so here, and I suspect it's not a list. Is it a list? Okay, yeah, it keeps the type is stable. So if we give a list, it gives back the list, I suspect. Okay, perfect. And we don't want to store the result of this match in a byte in a variable anymore. We just want to return that. Okay. If we try to Let's run the test. Okay, we have a little issue here. So here, actually, we need a map and not a flat map because this doesn't return as IO. So here, for both of them, is a map. Okay, perfect. I'm going to stop the episode here. Maybe we can see later on if we can like refactor that to make that a bit clearer. What I'm just going to recapitulate what we did. We start by extracting here the SHA-1 sync into a specific file that we put in the domain folder for the moment. What we did after that is that we changed the command here to have hash text and hash file. We created a test here to be able to check that we're able to hash files and hash several files. So we started by one file and then we added another file. We extended that to be able to handle a list of files. We can see that we started from a function here that was able to handle only one string of hash, and now we are able to handle several strings, and we are doing that in parallel. So that's really good. I'm quite happy with that. Okay, so I think we reached another little milestone in our Git implementation by being able to hash files. The next thing is that we are going to write those in the Git object repository. I'm hoping to do that in the next episode. But in the meantime, thank you very much for watching, and feel free to leave any feedback in the comments below, and see you in the next one. Thank you very much. Bye bye.